Right. So this is from the NSC paper, sorry, past paper, sorry. November 2021, and this is also paper 1. No, this is paper 2, pardon me, because we're doing statistics. So this is from paper 2. Okay, I'll be randomly, I guess, asking you guys to give me your input and, methods of working out the different things over here. So question number 1, Sam recorded the amount of data in megabytes that she had used on each of the first 15 days in April. The information shown in the table below. Okay, so here we have the data in megabytes that she used. Can I just read it again? Because I don't fully understand it. So Sam recorded the amount of data in megabytes that she used on each of the first 15 days in April. Okay, that makes sense. Okay, I don't know why I found it so hard to understand the first time. So let's say on the first day of the month, she used 26 megabytes. On the second day, she made use of 13 megabytes, and so on and so on. So let's say this is Monday, then that's Tuesday, Wednesday, Thursday, Friday, and then so on. Okay, 1.1.1. Calculate the mean for the data set. Okay, now we understand that mean is average, and to work out an average, you can simply, I guess, add up all the numbers here, add up all the data, and divide it by the number of terms. Okay, so you add everything up and you divide it by 15, since there was 15 days in April. Okay, go ahead and do that now, please. And then Andile, would you like to give us your answer once you've done this? I think what's really bad is I don't have the memo for this question, but that doesn't matter. We'll be able to gauge if our answers is wrong by, I guess, just making sure that we do everything accurate enough so that there isn't any mistakes.
I got 25.
25. Okay, you got a whole number. Now, how about the rest
Yes.
of you?
I also got 25.
Awesome. Okay, so the mean data would be 25 megabytes. Sorry, did you want to ask me something?
I just put in my, like, when you use stat and then you put it into a
Yes.
variable. I just did that.
Yeah, you can do that as well. I just forgot about that now. Yeah, so you could use a calculator also if you go to stat mode. And then the mode you want to go to is one variable. Okay, because here the only variable we are dealing with is the data for each day. Okay, the data used for each day. So yeah, you just go to that option, you punch in all your X values, and then you'll have to press shift 1. I think variable would be option number 4, and the mean is this symbol. So that's a symbol you need to look for in your calculator, and from that you'll get the 25. Okay, so it's awesome that you punched it in your calculator, because now you can give me the standard deviation right away. Okay, since all the data is in your calculator already, would you like to, Andile, also give me the standard deviation, please?
17.65.
17.65. Okay, megabytes. Now remember, standard deviation talks about the spread of the data. Okay, we understand, according to statistics, approximately 67% of the data would stand within one standard deviation of the mean. And I can't remember the exact numbers, but it might be 95%, if I'm not mistaken, will stand within 2 standard deviations of the mean. Okay, and then like 99.7, something like that, within 3 standard deviations of the mean. Now let's have a look at the next question over here. Determine the number of days on which the amount of data used was greater than 1 standard deviation above the mean. Greater than 1 standard deviation above the mean. Okay, so that's very specific. Looking at the 15 days, and I'm just going to draw this line over here. So that's how, if that line represents our data set, right in the middle would be the mean, which is 25. And then 1 standard deviation above would be if we add 1 standard deviation to this. So it means you're going to add that 17 point something. Can't remember the exact decimals, but can you guys just add the standard deviation and then give me this barrier over here, the answer to that barrier?
42.65.
42.65.
Yeah.
Thank you so much. Okay, now all the data that is, I guess, greater than 42.65, this is the data that they're talking about that is above 1 standard deviation. Okay, because we've added 1 standard deviation, and now we check what this barrier is. And so now all the data that's greater than this, they lie with, above 1 standard deviation. So let me count how many of these days, I guess, lies in that bracket. So it's not 26, it's not 13, it's not 3. None of these values here, they're too small. 58. 58 is I guess 1 day that's above that 42.65. 16 no, 10 no, 15 no. Here's another one, 69. 20 no, 17 no, and 40. So there's actually just 2 days that lies above 1 standard deviation of the mean. And so that's how you answer this question. You'd say 2 days lies above 1 standard deviation of the mean. If they simply asked how many days fall, outside 1 standard deviation, now outside can mean above and below. So you would then have to calculate 1 standard deviation below as well. And I guess work out whatever this value is here for this barrier, and then count these days as well that fall below 1 standard deviation. Okay, and if they said above or below 2 standard deviations, it means you have to add that 17.65 twice. So you just add it twice, and then you also have to minus it twice if it's above or below. Okay. Right, moving on. Question 1.1.3, calculate the maximum total amount of data that Sam must use for the remainder of the month if she wishes the overall mean of April to be 80% of the mean for the first 15 days. Okay, guys, I want you to reread this question and then attempt it yourself. It's 3 marks. And I'd like to hear then from you, I guess, your methods, I guess, after calculating your answers. So I'll give you a chance now to go ahead and work that out. So how we tackle this question is, sorry, they say calculate the maximum total amount of data that Sam must use for the remainder of the month. Now remember, this is April. They told us for the first 15 days of April. So the remainder of April, April has 30 days. So that will be another 15 days. Okay, because this was the first 15, and then there's still another 15 days to make it 30. If she wishes the overall mean, overall for 30 days of April, to be 80% of the mean that it was for the first 15 days. So it's almost like she's budgeting and she's looking, whoa, wait, I'm using way too much data. My mean year was, what was it, 25 megabytes. And she wants it to be 80% of this. Okay, now if you multiply 25 with 80%, I think the answer is 20 megabytes. Is that correct? If we multiply 25 with 80%. Is that correct?
Yes, yes.
Okay, so she wants to be spending this amount of data on average for 30 days. So let's work out, what her total expenditure will be for the month. If she's spending 20 megabytes for 30 days, it's going to be 600 megabytes in total that she'll be using for the month. Okay, now she already spent, I think she already spent, what is 25 times 15? Because I'm just thinking what the average was, and it was for 15 days. So what
Yeah,
was, is that 300?
375.
375, okay. So she already spent this much, which means if she wants to average 20 megabytes every day, she now only has, let's see, if we minus this, we'll get 225. This is the remainder that she can now spend. So you can divide that by 15. If you divide that by 15, I think the answer will also be 15, because 225 divided by 15 is also 15. So she's gonna spend, I guess her maximum mean will be like 15 megabytes per day for the remaining 15 days. Okay, but I don't think they asked us for this mean. They asked us for the maximum total. So it's this 225. Okay, so the 225, that is your final answer. If they did ask us what mean does she now, have to, or what's the average that she should now be spending, then you would say it's approximately, or not approximately, it is exactly 15 megabytes every day. If she wants to reach the goal of averaging a mean of 20 megabytes per day. Does this question make sense? Sipusetu, what do you say? How do you feel about this? And Jenna, what would you say? Was it okay?
Yeah, I did think like about how it was 30 days and 20 out of 25 is 80. But then I didn't like think about how to get to the remainder of how much she could, like that was confusing
Oh,
me. Yeah.
so if you add up all of these, it should be this amount.
Yeah, I understand now after you explained
Yeah.
it, but I figured out myself
Okay.
like
I didn't add up all those. I was just remembering what the answer was for the mean. You told me the mean was 25. So I simply just multiplied that by 15. And that also gave me this answer of 375. Yeah. Okay. Glad you got it after the explanation. These questions are not hard, but the fact that you have to do it within like 3 minutes or 4 minutes, that's what makes it hard. Right, question 1.2. The wind speed in kilometers per hour and temperature in degrees Celsius, for a certain town were recorded at 4 o'clock, I guess, p.m., because it says 1600, for a period of 10 days. The information shown in the table below. Oh, the information is shown in the table below. Okay, so this is the first day. When the wind was traveling 2 kilometers per hour, the temperature was 28 degrees. When the wind was going, I guess, a bit faster, 6 kilometers per hour, the temperature, decreased a little. So went 26 degrees. And then here, when it was blowing for 15 kilometers per hour, the temperature dropped even lower. Okay, so you get the feel that when the wind is not blowing so much, it's going to be a relatively warm day. And when the wind is blowing, like on this day, for instance, 25 kilometers per hour, notice that it's 16 degrees. So temperature definitely goes down, all depending on the speed of the wind. Okay, now how do we do this more, or how do we put it in, how do we put it in numbers form? Okay, where we can make predictions from the data. Okay, so first question. Determine the equation of the least squares line of regression for the data. Okay, equation for the line of least squares regression. So this formula is y equal to a plus bx. So in your calculator now, go ahead and work out the a and the b. Okay, you'll now have to use, hopefully you know this already, but you'll have to go use stat mode. And I think it's the second option, the second option will give you this equation, a plus bx. Okay, if you get a table asking you for x and y coordinates, the x coordinates would be the wind speed, and the y coordinates would be the temperature in degrees Celsius. Okay, once you're done punching all of that, you know to press AC, shift 1. There should be an REG for line of regression. Okay, so select that, and then you're either going to select A and B depending on which answer you're looking for. All right, so Sipo, if your microphone is not working at the moment, please type your answers in the chat. But Andile, what is your answers for A and B?
I got A to be 29.35 and B to be negative 0.46.
Sorry, what do you say, Jenna?
I just said I also got that.
Awesome. Okay, I like it when we can agree. Right, that's the equation for the line of least squares regression. And look, your calculator did all the work for you. That is 3 marks. Lovely stuff. Okay, there is actually very decent formulas to work out A and B. It's super rough. You will actually see it in your formula sheet. So yeah, I'll perhaps show you the formulas afterwards. But yeah, there's actually formulas to work that out if you didn't have a calculator. But it's so rough. It's so rough. Okay. 1.2.2. Predict the temperature at 4 p.m. if on a certain day the wind speed of this town was 9 kilometers per hour. Okay, so remember X is the wind speed and Y is the temperature. So they're basically saying if the wind speed is 9 kilometers, so if you substitute X with 9, what would be the temperature in degrees? What would be the Y value? Okay, if we substitute X with 9. You got anything? $25.51. 25.51. Jana says it's 25.51. Can I roll with that answer? The rest of you okay?
I got 25.21.
No, I made a mistake. I typed in 658035. Sorry, it's East, 21.
21. Okay. I like that you were so confident. You were ready to fight her now. No, I'm joking. 1.2.3. Interpret the value of B in the context of the daughter. Okay, so I like this question. Interpret the value of B in the context of the daughter. So you remember that I mentioned this is, very typical like of equation of a straight line. A, the y-intercept, B, resembling the gradient. So B talks about, I guess, either the general increase or decrease. And in this case, we're talking about temperature. So the general increase or decrease in temperature. Now that negative 0 point something shows that the temperature decreases as the wind speed increases. So I would say something like that in words. It shows that as it's almost like there's an inverse proportion. It's like maybe I'm talking nonsense now when I said that, but it's like, yeah, as the wind speed increase, the temperature in Celsius on that particular day decreases. And it makes a lot of sense logically also. You know that on a windy day, it's much more, colder than what it would be on a day without that wind. We did a lot of questions like that the last time, but here's a bit of a different question. This one is, I guess, not related to the bivariable data. This is not just a single variable question, I guess. So let's have a look at question 2 now. It says, the number of days that a grade 8 learner were absent at a certain high school during a year was recorded. Okay. The information is represented in the table below. So the number of days absent and the number of learners. All right. So the number of, or here it says that 34 learners were absent between either 0 to 5 days. Okay. Is this for the whole year? Yeah, it's during the whole school year. And then it says about 45 learners, so this is more learners, that was absent between 5 to 10 days. Okay. And then 98 learners, this is a very bad school. Or maybe is it just me that went every day to school? 98 learners were absent for between 10 to 15 days. Okay, at least it's starting to decrease now because 43 learners were absent between 15 and 20 days. And then 7 learners absent between 20 and 25 days. And then just 3 learners absent for 20 to 30 days. Okay. I would assume that those learners have valid reasons, perhaps like, an operation were done or something like that, where they really couldn't come to school for, I guess, long periods of time. Now, question 2.1, write down the modal clause for data. So we describe a mode as the term, that appears the most, or I guess the one that has the highest frequency. Okay, so if you look at our X column, it's definitely these people that stayed between, or yeah, that stayed absent between 10 to 15 days, stayed absent for, I guess, roughly that amount of period of days. Because there was 98 learners. Okay, for all the others, it's much less. Like 45 is the next best thing. But yeah, so this one definitely has the higher frequency. So we would say that the modal class is this class of learners that stayed absent between 10 to 15 days. So your answer would be literally just to write down this block. Okay, that's your modal class. And I think it's just a 1-mark question. Yeah. Moving down, question 2.2. How many learners were absent from school for less than 15 days? How many learners were absent from school for less than 15 days? Less than 15 days. It's these groups of learners. Okay, these are the good students. That's how many learners. If we add those amounts, the 34 plus the 45 plus the 98, and you get a total for that, that's the number of learners that were absent for less than 15 days. Okay, if there's anything that doesn't make sense or doesn't sit well with you, please ask. Okay. Because I'm human also, so I could make a mistake. And if you feel like I made a mistake, please ask. Either I will correct it or explain why I believe my answer is the correct one. Question 2.3. How many grade 8 learners are at the school? How many grade 8 learners are at the school? Oh, so I guess we just work out the total. You could add the number of learners to work out the total. So just add everything up. Yeah. 34 plus 45, that should be 79. Yep. And if we add that to 98, that should be 169. If you then add it to the 43 and the 7, which is 50, that should be 219. And then you add the 3, it's 222. Okay, you do not have to do this manually. I feel like it would be better if you just use the calculator. Now, for the next question, I feel like we're going to have to draw an ogive. Yep, it says here, draw an ogive. So in order to draw this ogive, I actually need to first work out a cumulative frequency column over here. So I want you to redraw this whole table now in your books. Okay, this is going to be the cumulative frequency column. So we're always going to start with the same value there, 34, but then the next one is going to be these two added. And then you just keep adding the next term as well.
I get 177
Oof, 177 for?
for the instead of the 169.
That is correct. Thank you so much. It's 177. I don't even know how I got that. Yep. Okay, so now when you add the 43, should it now be 200 and
210.
10?
220.
Okay, 20. Okay. So then 227 and then 230. Okay, this is what I get for not having a calculator with me. And for just being bad at adding numbers. Okay, so there you go. That's your cumulative frequency table. Now, please make a point of copying down everything else. If you are done, then you can go ahead and draw your ogive. Okay, your coordinates for the ogive is going to be 5. So you take the last digit here, 5 and the 34. That's the first coordinate. The second one is going to be 10. Again, you take the last digit, and 79. Then the next one will be 15 and 177. And then you just go on like that. 20 and 220. Just continue all the way. Once you've plotted all the coordinates, you will then draw a nice curve afterwards. Okay. So my X column is going to go from 0 to, I think, 30. 0, 5, 10, 15, 20, 30. And then my Y column has to go at least up until 230. So I'm going to count in 50s. 50, 100. Oh, that's too big. 50, 100, 150, 200, 250. Okay. So 5 and 34, that's the first coordinate. Actually, the first coordinate is going to be 0 and 0. And then we go 5 and 34, 10 and 79. Just keep plotting. Okay, mine is really not accurate. But I also don't have the tools to be accurate. If you have line or grid paper with you, you can do a lot better than what I just did. Okay, I'm not so sure if I want to erase this just yet. Let me at least read the next question before I do that. Yeah, so now they say, use the cumulative frequency graph to determine the median number of days the grade 8 learners were absent. The median number of days. Oof, okay. So the number of learners is over here. Number of learners. Okay. And since there was 230 learners, the median would be 115. Okay, the learner that's right in the middle would be 115. So I'm going to make a mark here by 115, which is the half of 230. Okay, so this is my median. Now, if I, draw a line parallel to the x-axis from the 115 to where it touches the line, and then I bring that down. Again, this line has to be parallel to the y-axis now, perpendicular to the x-axis. And then wherever it reaches, I think that's like 12. That's 12. So you could say the median number of days, it's about 12 days. Yeah, that's like approximately in the middle. Let me just read the question again. Question 2.5, it says, use the cumulative frequency graph to determine the median number of days that grade 8 learners were absent. Okay, so I went to the grade 8 learners. That's the 230 learners. The median would be in the middle there, which is 115. You go towards the line from the 115, then you go down towards the x-axis to check the number of days. Okay, so on top you have the number of learners. At the bottom, you have the number of days. And that's what we're after. So it's 12 days. What do you guys get on your graph? Do you also get 12 days, or do you get 13 days? Or 14 days perhaps? Is it somewhere
I get
close?
12.
You also get 12. Cool. Cool. So I didn't do too badly, even though my graph looks so ugly. Okay. I'm going to move over to probability now, because I said we're just doing practice over these 3 topics. It looks like we might not get to do the financial math question, but that's okay. This could probably be done for homework. So yeah, moving on to probability now. So now you kind of have to put on a completely different hat, that because this question is going to require us to use some other skills now, or at least think about some other techniques and formulas. 11.1 says 2 events A and B are such that events A and B are independent, and then the probability of not A, so the probability of event not A happening is 0.4, and the probability of event B happening is 0.3. Calculate the probability of A and B. Okay, I first want to pause with this first thing that was said. They're talking about event A and event B, and they're saying that it's independent. Jana, what does that mean? Or how is that useful to our calculations?
I can't really remember this well.
Okay.
But I think, yes, I know like it means like it either like equals 0 or something like that if you like add them or multiply them. I can't
They-
remember because I wasn't in that lesson when you went over.
Oh, no,
Yeah.
in fact, in that lesson, I didn't even go over this. I only
Oh.
did the counting principle, which deals with like factorials and all of that, but I didn't go over this work. That's
I think
absolutely fine.
they don't, like they have no like connection. I don't know. They can do things without relying on one another, but I can't remember.
Yeah, that's basically the definition of independent, and it
Mm.
holds some weight here. But in terms of how we go about, working with this, if you know that two events are independent, in this case A and B, then we can say that the probability of A multiplied by the probability of B is equal to the probability of A and B. Oh, I'm running out of space there, but I hope you get that last bit in as well. So the probability of A multiplied by the probability of B is equal to the probability of A and B. All right. So that is one useful thing that we can, I guess, make use of here. Now, the thing is they don't give us the probability of A. They only give us the probability of event B happening. So how do we work out now the probability of event A and B? Okay, so here, the probability of event not A. Ooh, there we go. So the probability of not A is equal to 1 minus the probability of event A, because this one represents like 100%. Okay, so if you minus the probability of A, which is, I don't know, you can whatever A's probability is, if you minus that one, you'll get the probability of not A. So it's like 100% minus whatever A's chances is. If you take away A's chances, you end up with the probability of not A. I hope this makes sense. Okay. So this is also one of the useful formulas that we can use. So I'm going to work out the probability of A this way. So not A is 0.4. So that's equal to 1 minus the probability of A. Okay, so to work out the probability of A, I'll just take it over to the right-hand side. It's then now positive. And then I'll take the 0.4 across. That becomes negative. And 1 minus 0.4 is equal to 0.6. So the probability of A is equal to 0.6. Okay, now for us to work out the probability of A and B, we can now simply take the probability of B, which is 0.3, and multiply that by the probability of A, which is 0.6. And that should give us 0.18. I hope. Again, I don't have a calculator, but I think this is correct. Double check that for me. And if you have any questions regarding the structure or methods that I'm using, please ask. Okay, also write down this piece of information here. Don't just copy down the numbers. I guess this is more useful because you can apply it to different questions. If they give you the probability of not like any other event, let's say not B. Yeah, so for example, in this case, the probability of B is equal to 0.3. If I ask you for the probability of not B, then that would be equal to 0.7. Okay, because the chances of it happening or not happening is 100%. So that's why, in other words, it's 1. So if you say 1 minus that probability, you get the probability of it not happening. Okay, now you mentioned something. I think it was you, Jenna. You mentioned it now when I asked for about independent events. You said something about being 0. That is for mutually exclusive. So here we deal with independent, but you also get mutually exclusive. Okay, and this simply means when two events can't happen at the same time. That's like when the probability of event A and event B happening is 0. So it's impossible. In other words, let's say you you throw a dice. What's the chances of you landing on an even and an odd number? It's impossible. You can't land on an even and an odd number. The number will either be even or it will be odd, but it can't be both. Okay, if you throw one dice, or one die, I should say, the number on top will either be odd or it's going to be even, but it can't be both. Okay. And I guess that goes for a lot of other things. The light can either be on or off, but not both. It could either, if you're having a child, it's either going to be a boy or a girl. But yeah, can't be both genders at the same time. Or at least so I hope. 11.2. A survey was conducted amongst 50 learners at a school. Sorry, 150 learners. The following surveys were made, or observations were made, pardon me. The probability that a learner selected at random will take part in, okay, so here they give us a different statistics. I'm not going to read it one by one because I think they later on give us a Venn diagram to show us all of it. But the different sports is hockey, debating, chess. Okay, those are the 3 different sports: hockey, debating, and chess, and they represented with H, D, or C. Okay, now let me go down to the Venn diagram and just explain what we see over here, because everything that they put on top is given in this Venn diagram. So I want you to copy down this Venn diagram now. The big box is what you call the sample space. That's why there's an S next to it. Okay, the sample space is I guess the amount of people that you surveyed, which in our case is 150. That's how many people were surveyed. Okay, this is 100% of the people. The 3 sports is hockey, debate, and chess. One of my favorite sports. Right. Now, they say 0.24 or 0.24 learners play hockey only. This 0.24 is the number of learners that play hockey only. It's not the total number of people that play hockey. It's only the people that only play hockey. Because this 0.02, they also play hockey. The 0.14, that's another group of people that play hockey. And the A value that is unknown at the moment, that is also more people that play hockey. However, they play other sports as well. For example, the 0.02, they play chess as well. The 0.14, they play, what is D now again? Oh, they debate as well. They do debating. And then the A, the number in the middle, they do all three sports: hockey, debating, and chess. Okay, so hope you get the picture. And here's M outside, it's another unknown variable. They do not play any of, or they don't do any of these three activities. They don't play hockey, they don't play chess, and they don't do debating as well. So out of this 150 people, M of them do not play or do not do any of these sports. Right. Also, here's some more information given. It said here that the number of people that debate only and the number of people that play chess only are the same. Okay, so whatever this decimal is going to be, it's going to be the same here as well. All right. Now I'm just going to erase all of this, and then we're going to answer the first question. Determine A, the probability that a learner selected at random participates in all three activities. Ooh, I feel like this is too little information for us to determine A's value. So let's read here above if there isn't anything here that could help us. Okay, so I want you guys to please answer here. I'm going to pause and let me know when you have a solution. I just noticed here. Here's
I
something
think
that
that
might
one
help
in the
us.
circle, the hockey players, is equal to 1.
The hockey. Sorry, this? What we're
That
saying about
one
this?
circle, yeah, that one must be equal to 1.
No. All
No.
of these together, everything added up together in here, this should all total to 1.
Oh.
Everything in the whole box, that should total to 1. I think the piece of information that's going to help us calculate A is this third bullet over here that says 15 learners participated in all three activities. So they're talking about this group here. That is the group that overlaps with hockey, debate, and chess. Notice when I draw these circles, all these circles overlap that the piece in the middle, basically. So that's the 15 learners. Now, how do I write that 15 learners as a decimal? Like all of the others are written as decimals.
0.15.
But wait, there was a total of 150 learners.
30.
So it's going to be 15, not out of 100, but out of 150. And this is going to
0.1.
give it. Yep, there you go. 0.1. Right. Let's see if we can answer this question further. The second bullet says, let me just read it again. The probability that a learner selected at random participates in at least one of the activities. At least one of the activities. That is 0.7. How can that piece of information help me with one of these unknown variables, B
It's,
or M?
wouldn't it be 0.7 minus 0.24 divided by 2?
Minus 0.24. Divide. Oh, but you're forgetting about these people in the middle here. You're forgetting about all these people here. We need to include them as well. You'd have to, so if you're going to minus a 0.24, you have to minus this people, the 0.02, the 0.14, and the 0.12. You have to minus all of those people. Oh, and what about A also? You have to minus the 0.1. So you have to minus all of them first. And then you divide it by 2 to work out B. Okay, so go ahead and do that. Let me know what your answer is.
Sorry, sir, can you explain again?
Okay, so here they're saying, oh, I'm scratching it out instead of highlighting. But here they are saying the probability that a learner selected at random participates in at least one of the activities. So at least one of the activities means everybody in these 3 circles. Okay. Now the probability or the probability of the people participating is 0.7. Which then means if you want to work out B, you can minus all these other people from the 0.7, including A's value, which is 0.1. You'll be left with the 2 B's. So that's why when you minus all of those things, you then have to then divide it by 2.
Okay, I'm done. Thank you.
Okay. So you minus the 0.24, minus the 0.14, minus the 0.02, minus the 0.12. What's your answer for that? After dividing this by 2? Oh, there's a 0.1 also, minus the 0.1. That's A's value. Then you divide by 2.
I got 0.11, but I don't know.
0.11.
But maybe I didn't minus all of them.
Let's see. How about the rest
I
of you?
also got 0.19.
19.
Yeah.
0.19. Okay, I thought you said 0.11 first. Okay. We'll see if this is right or not at the end of all of this. So keep in mind everything inside the circles, they should add up to 0.7. Okay, so that's one way of checking if your answer is right. If you add up everything, including the A and the B, it should give you 0.7. Then that then means that M's value is 0.3. Okay, because if you add everything up in this box, it should total to 100%, which is 1. Okay, so it should total to 1. Your sample
I got
space
B
should.
as 0.04.
I feel like that is the correct answer. I really feel like that is the correct. Guys, don't you want to double check your things, please? Because I remember doing this previously, and I don't remember 0.19 as the correct answer. So here you're going to take 0.7 minus this, that, and that.
Oh, now I got 0.04.
Okay. Okay, cool. There we go. That should be the correct answer. Right. And M's value we said is 0.3. Okay. So now it means that if you add all of the things in this bracket, including A, B, and M, it should total to 1, which represents 100%. Okay, and we know 100% of this population is 150 learners. Okay, now what's the next question? Determine M, the probability, oh, we did that already. Okay, so this one says, how many learners play only chess? Only chess? That's B. Okay, but they're not asking us for the probability. They're saying how many learners. So we know this is now equal to 0.04. How many learners is 0.04? That 0.04 is the probability of a learner randomly, if you randomly select play chess. But what is this in terms of number of learners?
Don't you times it by 150?
That's correct. So the number of learners that play chess only, what do you get?
6.
Correct. Okay, that brings us to the end of this lesson, guys. I'm glad we got to do a little bit of probability. I think you should definitely work on Venn diagrams and tree diagrams, and as well as the probability rules that we covered here with 11.1, independent events, mutually exclusive events, and just any random events. I think you guys really need some more practice on that. But otherwise,